Restless supermassive black hole found mysteriously wandering in space. We tend to think of supermassive black holes as relatively stationary things, sitting there bang in the middle of a galaxy while everything else swirls around it. But that's not always the case, and now astronomers have the best evidence yet for a supermassive black hole that's not only moving through the universe, but moving around within its own galaxy. It has ants in its pants and witches in its britches, and while it's not clear why, the possible explanations are really exciting. We don't expect the majority of supermassive black holes to be moving. They're usually content to just sit around, explained astronomer Dominic Pes of the Harvard and Smithsonian Center for Astrophysics. They're just so heavy that it's tough to get them going. Consider how much more difficult it is to kick a bowling ball into motion than it is to kick a soccer ball, realizing that in this case, the bowling ball is several million times the mass of our Sun. That's going to require a pretty mighty kick. Catching a peripatetic supermassive black hole in the act is no easy feat. They can only be found across vast gulfs of space, millions to billions of light years. At these distances, isolating the motion of one object, even if that object is a supermassive black hole, in a whole galaxy is a challenge. Pes and his team thought they might have some luck with a type of galactic nucleus called a megamaser. This is a type of active supermassive black hole with an accretion disk of gas and dust being slurped onto it, generating vast amounts of heat and light. With a megamaser, there's an additional ingredient to this formula: molecules such as hydroxyl, water, formaldehyde, and methane that amplify the nuclear's luminosity in microwave wavelengths. Using a technique called very long baseline interferometry, which combines observations from a network of radio telescope antennas to effectively create one huge observing dish, the velocities of these megamasers can be measured very precisely. By studying water megamasers in particular, Pes and his colleagues hoped to be able to identify any supermassive black holes moving at a different velocity to the galaxy surrounding them. We asked, are the velocities of the black holes the same as the velocities of the galaxies they reside in? He said, we expect them to have the same velocity. If they don't, that implies the black hole has been disturbed. The team looked closely at 10 megamasers, comparing the black hole velocity data against observations of the entire galaxy. Sure enough, 9 of them were consistent with our expectations of supermassive black holes lurking in the galactic center, like a spider in a web. One of them, however, showed different behavior. The spiral galaxy J0437 plus 2456, located around 228 million light-years away, has a supermassive black hole around 3 million times the mass of the Sun, which seem to be moving at a significantly different velocity from the rest of the galaxy. According to the team's analysis, the velocity of the supermassive black hole is around 4,810 km per second, 2,990 miles per second. The galaxy's neutral hydrogen, on the other hand, appears to be receding at a velocity of 4,910 km per second. According to observations of star and gas movements, the velocity of the inner region of the galaxy is 4,860 km per second. Because all these measurements differ from each other quite significantly, and the galaxy's entire velocity structure seems quite complicated, it's difficult to tell exactly why everything is wobbling around in there. There are several possible explanations. The galaxy could be experiencing an ongoing encounter with another massive object, like another galaxy. The supermassive black hole could have collided with another supermassive black hole, generating a recoil kick that pushed the black hole out of position. The wobbling could be the galaxy and black hole settling back down. Or the black hole could have an unseen binary companion, the two objects orbiting a mutual center of gravity within the galactic nucleus. Despite every expectation that they really ought to be out there in some abundance, scientists have had a hard time identifying clear examples of binary supermassive black holes, Pes said. What we could be seeing in the galaxy J0437 plus 2456 is one of the black holes in such a pair, with the other remaining hidden to our radio observations because of its lack of maser emission. If it's a recoil kick or a binary companion, that would be extraordinary news for astrophysics. There are many unanswered questions about supermassive black holes, such as how do they get so big, and whether supermassive black hole binaries can close the final parsec of distance between them. Evidence for supermassive black hole binaries and mergers could help us answer these questions. It's great news for us here in the Milky Way, too. As we are a few billion years away from a galactic merger, there's very little chance that our supermassive black hole, Sagittarius A*, will develop wanderlust anytime soon. The team hopes to take more observations of the galaxy and its peculiar nucleus to try to narrow down the cause of its strange behavior. The research has been published in the Astrophysical Journal. Alright, that's all for today, guys. Thank you for watching and don't forget